2007.2, percents, decimals, and the percent equation. Now, we've already learned how to solve the three main types of percent problems using the percent proportion. That's that part over base equals the percent over 100. Over here, part over base equals percent over 100. Or what I was calling the is over of equals percent over 100. But they can also be done another way that involves what's called the percent equation, which I'm going to show you. Now, to use the percent equation, you have to be able to change percents into fractions and decimals. Now, we've already practiced changing them into fractions back in lesson 1, but to change them into decimals, really very easy. We're going to practice that, review that skill here just a little bit, and then I'm going to show you how to solve the three types of percent problems. The type where we don't know the percent, the type that we don't know the part, the type that we don't know the base. Now, to change a decimal into a percent, to write a decimal into a percent, you move the decimal point always 2 places to the right and add on or affix a percent sign. So to change a decimal into a percent, move the decimal point 2 places to the right, put on a percent sign. To change a percent into a decimal, just to reverse this, you move the decimal point 2 places to the left and you drop or remove the percent sign. So I have some examples here. I'm going to kind of remind you here. Now I'm going to change these decimals into percent. So decimal point goes 2 places to the right, add on a percent sign. So here's the decimal point. I'm going to scoot it 2 places to the right. It's now in between the 2 and the 1, so I have 2.1%. It's that simple. Here's another example. 1.55, I'm going to move the decimal point 2 places to the right. That's going to put it on the end here. That's going to be 155%. Now, if the number that you're trying to change into a percent doesn't have a decimal point, if it's a whole number, just add the decimal point on the end and put a couple zeros here as placeholders, because I'm going to move it 2 places to the right, and that's going to give me 600%. So it's very simple to change a decimal to percent. Just as easy to change a percent into a decimal. Now, I'm going to slide the decimal point 2 places to the left this time. I'm going to remove the percent sign. Now, there's no decimal point written here, but it would be on the end because it's an integer here, 54. So I'm going to slide it 2 places to the left. That puts the decimal point in front of the 5. I'm going to drop the percent sign. I'm going to get 0.54. I always put the 0 there in the whole number spot, in the ones, if there is no one number there. And that'll give me like a place value position there of 0.54. Now I'm going to do the same thing on example B here, except I'm going to have to add a 0 as a placeholder because I'm going to slide the decimal 2 places to the left, drop the percent sign, 2 zeros there, so I'm going to have 0.0095. And that's what it changes into. The next example, 220%, kind of like the first example. No decimal point, so I'll put a decimal point in. I'm going to move it 2 places to the left, drop the percent sign, I get 2.20, or better yet, just 2.2. The percent equation, that's what I want to show you now. It says you can represent A is P% of B using the equation A equals P%. This is where we'll change it to a decimal or a fraction if necessary, times B, which of course A is the part and B is the base and P% is the percent. So instead of setting up a proportion, I'm going to use this equation. I have 4 examples here. I have the 3 main types of problems. The first 2, we are going to try to find the part. We're going to try to find the is number. So I'm going to set this up. What number is, now this is the part, so I'll call it A. Is means equals 16%. I'm going to slide the decimal point 2 places to the left, drop the percent sign, I get 0.16 of means times, and that of course is my base number here, times the base, 75. So now it's just a matter of multiplying these 2 numbers together. We did something a little bit like this way back at the beginning of lesson 1, 7.1. So I'm going to multiply 0.16 times 75. That's a 0, carry a 3, that's an 8, that's a 2, carry a 4, that's an 11, that's a 0, that's a 0, carry a 1, that's a 2, that's a 1. I have 2 decimal places. I get 12. A is equal to 12. And that's the number. 12 is 16% of 75. All right, let's try a similar problem here. Okay, what number, that's my part, is, means equals 65%, slide it twice, 0.65 times my base here, which is 84. So again, maybe the worst part of this problem is the arithmetic. So 0.65 times 84, that's a 0, carry a 2, that's a 6, carry a 2, that's a 0, carry a 4, that would be 52, 0, 6, 4, 5 with 2 decimal places. So I get 54.60, or A equals 54.6. And 54.6 is 65% of 84. It doesn't always have to come out to be an integer. Sometimes you get a decimal. That's one nice thing about this method and your arithmetic. Now we're going to change the problem. Instead of saying what number is, we're going to find what percent of 48, that's my base, is 45, that's my part. So using this, I get 45, that's the part, equals my percent. This is what we don't know, so I'll call it P. Now remember, this is a percent. When I get done with my arithmetic, I'm going to have a decimal, and I'm going to have to change it and put it into percent form. And then this is times the base, which is 48. So now I'm going to have to divide to solve for P here. It's a regular equation. I'm going to divide both sides by 48. P times 48 is the same thing as 48P divided by 48. You can see why I'm dividing by 48 maybe a little more clearly now. And I have 45 divided by 48. So unfortunately, I've got some arithmetic. 48 into 45. 48 doesn't go into 4, doesn't go into 45, but we'll go into 450. I'm thinking probably 9 times. That's a 2, carry a 7. That would be a 43. Yep, 9 times it looks like. So that is an 8, and that's a 1, and I bring down a 0. Let's see, 48 goes into that, looking like maybe, well, I don't know. I don't think it will go in 4 times. I think in 4 might be a little too much. Let's try 3. So that would be, let's see, a 4, carry a 2, and that's a 14. I subtract, and that's 6, and that's a 3. It is. I'm going to need another 0, it looks like. Bring this 0 down. It goes into that, I think, about 7. 7 times 48, let's see, that'd be a 6, carry a 5, a 33. Wow, this one's taking a little bit longer than I would have wanted to, but what are you going to, there it goes, it terminates. 240. All right, so I get 93. Well, I didn't give myself any space here. Let me write it down here. 0.9375 is equal to P. Now, that's not how we're going to leave the answer, because the answer asks for a percent. And it's not 0.9375%. This is the percent, but it's in decimal form. So I have to convert it back. That's why we reviewed that just a little bit ago. I'm going to slide the decimal 2 places to the right and affix a percent sign, and I get 93.75%. Whew, that was a lot of work. Next example. In this case, I have the percent, I have the part, I don't have the base. So 27, that's my part, that's the A, is equals, now 7.5%. Now I know it has a decimal point, but it's got the percent sign, so I'll add a 0 here. I'm going to slide it 2 places. I get 0.075 of the what number times my base, times B. So now I'm going to have to solve this one. I'm going to divide both sides by 0.075, by 0.075 here, both sides, and I get the base is equal to, yikes, look at the arithmetic I got going here. 0.075 into 27. I'm going to have to add a decimal point and probably some zeros because I got to slide this one 3 places to the right. So I'm going to have to slide this one 3 places to the right. I may need more zeros, we'll find out. 75 doesn't go into 2, doesn't go into 27, but does go into 270 3 times. That's 225. That's a 5, that's a 4, and I'll bring down a 0. It goes into 456 times, and that's 450. Wow. Well, at least that was nicer. Bring down the 0, and of course that'll be a 0. So this gives me 360, and that's my base. 27 is 7.5% of what number? Of 360. Now 360% because they're looking for the base number here. I'm going to do one example here of an application involving percents. We're going to spend a lot more time doing applications in a later lesson. A hotel charges a couple $1,500 to hold a small wedding ceremony in a hotel garden. The couple must pay the hotel 12.5% of the charge as a deposit. How much is the deposit? Now, it's not written in the form with the is and the of, where you can identify the percentage or the part and the base number quite so readily. So what we have to do is we have to kind of paraphrase a little bit. It says the couple must pay 12% of the charge as a deposit. Well, this is the charge right here. Okay? And we're trying to find the deposit. That's what we're looking for right there. So we have the percent. There's the word of, so we know that that's the base number or the of number. And the deposit is what this percent of this base number equals, so that's our part. So this is saying, essentially, what is 12.5% of $1,500? That's what the problem is. I have to rewrite the problem. Either I do it mentally in my head or I write it down on paper and I do a little bit of paraphrasing, a little bit of rewording, and I put it into a form where I can more readily find everything that I need. Now, that's my part, is, slide it two places, 0.125 times the base 1,500. So now I just have to multiply those two numbers together. So I have 1,500 times 0.125. That's a 0, a 0, a 5, carry a 2, a 7, a 0, a 0, a 0, carry 1, a 3, a 0, a 0, a 5, and a 1, 0, 0, 5, 7, 8, 1 with 1, 2, 3 decimal places. So it turns out to be 187.5 with a couple of zeros. Now I don't need both of those zeros, but because this is money, I will write one of the zeros down. So the deposit is $187.50. I can't stress how important it is to get familiar with these three basic types of percent problems. We can solve them now if we use the percent proportion or the percent equation, but it's going to take some time on your part to practice, practice, practice.